My name is Brock LaMeres, and I will be your instructor this summer for the course CSCI 109, which is Introduction to C Programming for Engineers and Scientists. In this overview video, what I'm going to do is give you an orientation to the course, introduce myself as the voice that you'll hear in all the videos throughout the summer, and then look at the logistics of the course, including the Brightspace learning management system, the syllabus, and where you find all the assignments, when they're due, and the schedule, and what everything is worth. And so the goal is at the end of this course, you will be able to launch into the learning activities and start working through the material. So let's get started. Let's begin by looking at what this course is. All right, so this is an introduction to programming a computer. The expectation for this class is that you have never programmed a computer. So if you're a computer science student or a computer engineering student, this is not a course for you. The expectation is that those majors have already had their introductory level programming courses and are probably well into their curriculum. This is for electrical engineers or scientists who've never programmed a computer before. So it's going to go nice and slow, and it's going to give you a lot of background in terms of the tools that we use and what we're doing at each step. So to begin with, the term computer is what we use to describe this device, this machine that humans have built, which is a collection of hardware and software that work together to perform a task. So the hardware has things in it that you'll learn about, but you've probably heard of things like CPUs and memory, in I/O, input, output, but all that hardware doesn't really do anything unless you provide it with a set of instructions to execute. And so we provide what the hardware should be doing at any given time through these instruction codes, or what we call software. So a software development is where you put together basically a sequence of things that this hardware will do in order to accomplish a task. Okay, and what it can do at each step is relatively simple. It's basically like move information from memory over to another location, add two things together, store it back. But since the computer can go really fast, billions of these instructions per second can be executed, then the computer is very useful because it can actually do things in what we would perceive as real time from human timing standpoints. Okay, so having said that, there are computers at all levels. So when we think about a computer, we typically think about a laptop or a workstation that you're sitting at that has like a full monitor and a real keyboard. But you also realize that you also have a phone in your pocket that is also a computer. And so those two examples illustrate the range of computers. That you have large computers that are designed to do anything under the sun, that run operating systems. They run Linux or Windows. And then you have other smaller computers like your phone that run, iOS or Android, and though they're a little bit more limited in terms of what you can do with it, still very cool. And then it goes all the way down to extremely small dedicated computers, which we call embedded computers, that run all of the electronics that exist in our life. So the microphone I'm talking into has a computer in it. The camera that I'm using has a computer in it. My mouse has a computer in it. It turns out there's far more embedded computers in the world than there are the general purpose computers, and even more embedded computers, the little guys that are in everything, than smartphones. So anyway, all of these computers require you to program them. And so what we are going to do in this class is this is going to be the introduction to programming in a language that is called C. And C is one of the oldest languages that we have. It is, and just because it's old doesn't mean it's not the best. It is used for almost all embedded computing program. That means when you think about programming a computer, you always hear about the new, latest and greatest things and how everybody, what's the next thing? What's the next thing? If you want to have a living, learn C, because all of the computers, the vast majority of computers that are running in society today are embedded computers, and those are programmed using this stock language called C. So that's what we use when we teach it in electrical engineering, and actually all engineering. Computer science uses some different languages, but in regular engineering, especially electrical, we use the language C. All right, so what we're going to be doing is learning the basic constructs of a programming language. So we're going to learn things like What is it? You write the program. What do you do with it? You have to do a thing called compile to convert it into a form that can be executed. Then you look at the syntax that's supported. You look at setting up variables. You look at doing loops and how you do arithmetic and how you make decisions and how you access files and how you print stuff to a screen. And we're going to walk all through the basics so that you can actually be competent in programming, particularly these low-level computers such as, the embedded computers, things like Arduinos, Raspberry Pis, and the MSP430, which you'll learn about later. So that's kind of the overview of the technology that we're going to actually learn in this class. So now let's look at getting started with the class, and that is all going to come in the form of Brightspace. Okay, so Brightspace is the learning management system or website that we use. And if you look at the website here, it's basically ECAT for Bobcats. So it's ecat.montana.edu. You log in with your NetID and your NetID password, and then you come to Brightspace, and then you come over to the courses that are active for you, and you see this, okay? And so what I do in this tool is everything that you need is in here, including the syllabus, which we'll go over first. But I'm just going to kind of give you an orientation to Brightspace, and then we'll come back and look at it in detail. So when you come into the course, you'll see a welcome. So I'm going to have announcements every week that start, and then they go away each week. So anytime you log in, you should be notified what you're doing for that week. And then up here are going to be all the tools that we use. You really only need to use content. So when you log in, you'll see a welcome or an announcement that tells you what you're doing for the week. But content is really the only tool we're going to use. And the reason is because I have everything linked in here. Okay. So all of the modules that we're going to cover, there's 11 modules we'll cover, has a web page. All right. And then in the web page, if you click on it, everything's linked in there. Okay, so when you look at this, there are activities that you're going to do. You're going to watch videos. You might have optional reading, and then you'll do like multiple choice quizzes, and then you'll do programming assignments that you upload. But everything is linked in here. Now, these are links to sometimes files, sometimes YouTube videos, sometimes other tools in Brightspace. But what's neat in my mind is that you only have to know to go to content. All right. Now, having said that, an example is that if you did a quiz, you see the quiz tool up here, right? You could click on the quiz tool and go to and see all the quizzes that we would have in this class. But you can also just come down and click on this link and it'll take you to the quiz. So in general, what most students do is they just live within the content area of Brightspace, okay? So let's look at the syllabus first. So when I come in here, what I'm gonna do is I'm gonna come back to the main course, okay? And I'm sitting here and it's like, oh, welcome, week one. First thing to do, oh, hello, summer 2024. Check out the course information and syllabus page, and you'll find the information video. That's this. There's assignments due. Oh man, they're due on the 15th. I hope there's more details on that. So I'm gonna go ahead and click on this, or I can come back up to the content area. So I go to content. And I come into here. And so you notice that I have like the weeks listed out in here. So week one, this is course information. And when you come into here, you get, this is a content page. And you'll see that it's like, oh, okay, welcome. I do a little reading, course overview, what we're going to be looking at. And then you have information such as the course instructors. I'm Brock. You can call me Brock. And then our TA, Jordy, who's going to be helping you in grading. So you want to make sure you know her contact information. These are linked here on the content page because this is where you get access to us. So here's our email, here's our phone. We're going to be using WebEx to do video calls. And so if you need help, you just request a time, jump on a video call with Jordy or me, and you're off and running. Usually it'll be Jordy, so she's hired to help us throughout the summer. And then there's the logistics. And again, this is not as in detail as the syllabus, but this is a 12-week summer session course that runs during the summer of 24. And then you come down here and you start seeing the activities listed, and you'll get into this flow of like, this is how everything's listed. So you'll have what the section is, what you're supposed to do. So I try to like bold out a specific things you're going to do. Watch, read, do, watch, read, do, upload, right? And so you just basically walk through all these links in here. All right. So let's look at the course syllabus first, and then we'll look at where all the assignments are. All right, so here we are. This is the technical description of the course. And if you look at the outcomes of this, it's basically develop a computer program using the C syntax, debug computer programs written in C. That's an important step. It's more than just typing in the wrong syntax and having the system go, hey man, you misspelled something. It's more of like you write a program and it runs, but it doesn't do the right thing. And so we look at techniques of how you tell what your computer's doing. And then we look at the capabilities of C to set up and manipulate computer memory and to solve basic real world engineering problems. And so that's kind of the key of this is we're not just learning this for nothing. This is a tool that you'll have in your toolbox to solve problems. All right. Let's see. So just myself, I'm in Norm Asbjornson Hall in Bozeman, Montana. You don't have to be in Montana. You can take this class from anywhere. My contact information, blah, blah. The course starts May 13th and runs through August 2nd. And this is fully online. This is going to be there's no like WebEx synchronous lectures. It's all YouTube videos that I've created for you. All right. And that's cool. Okay. Yeah, the lectures are made for a code along approach. Okay. And what that means is that you're going to listen to me describe like some part of C. Like we look at like a variable. We're going to describe it, but that's not how you learn to program. You learn to program by programming. So I kind of describe it. Then I show you I have this code along thing where you will then code along with me, and then you'll be able to then practice on a low stakes homework problem on your own. And then you do a lab each week, which is more of the problem solving. Okay. Prerequisite. You can't be a computer science or a computer engineering major. Okay. This course is not for those majors. If you are, you need to drop the course. Okay. Because this class is meant for people who've never programmed a computer before. So you're in the wrong class. All right. We'll go through the server, but I'll show you kind of roughly how this is going to work. Not roughly, exactly. We're going to log into a Linux server and you're just going to code straight in text. It's nothing fancy whatsoever. We have a Discord. Okay, so one of the first assignments is joining the Discord. This is basically a messaging service. It works really well in programming classes where most of the questions that you have are really quick. Like, why doesn't this work? And you can post it to the class, and then the class will jump on and be like, you forgot your semicolon. So it's a really rapid response system, really used in like all CS classes. So office hours. There's no office hours. We're just always here. So if you need to talk, just email. This is the summer. There's no set times other than weekly deadlines. And so just reach out via email and we'll set up a time to talk. The grading in this class is basically you're going to have 40% is homeworks, 60% is labs. It's all coding. Okay. Grading, just straight grading. Textbook, there is no required textbook necessarily. There is a textbook that I use for a reference. You don't need to buy this. I provide it to you. It's provided through a library subscription that MSU has. So you don't have to buy anything for this. There's no required material for this other than a computer and an internet connection. And so, but I'll be referencing that throughout the course. Okay. Academic policies. Don't cheat, right? What's cheating? Cheating is where you turn in somebody else's information. You cannot solve problems today alone, right? Everything has to, all these problems that we face have to be solved with teams. So you need to work together. It's absolutely acceptable to work together, but work together basically means helping each other or discussing ideas. Where it becomes cheating is where you're like, hey, give me your assignment and I'm going to upload it, right? So you take credit for somebody else's work. So you can work with somebody and you can both be like typing in kind of the same information and come up with nearly identical programs. And that's not cheating. It's when you say, hey, I don't know, I didn't do the assignment. Give me your code. Okay. All right. Course components. Instructional videos. You're going to be listening to videos, lots of them. That's the replacement for the lecture, but they're better. They're not just lecture videos. They're code along videos. So the expectation is that you have your terminal up and you are coding along with me. And if you do this, then the homeworks are just slight extensions of the code alongs. Okay. I provide slides. Almost all the information you need for this course is provided in slides, and I talk over the slides in the videos. So those two resources are basically where you get all the information. I did mention there is reading in terms of I say read these sections in this textbook that I give you, and it's kind of optional. Sometimes when you look at a slide, it doesn't provide it in the format you might understand. So you might want to have it explained a different way. That's where the reading comes in. Homework, we will have graded homework, which are small homework or small programming assignments, and lots of them. Every single section will have a small programming assignment. And the idea here is to get you a lot of touches with programming where you start a program from scratch, code it all the way up, run it, get points, and off and run it. So a lot of low stakes assignments. And then you get to labs. Labs are more in depth, and this is where you're going to spend many hours thinking through a problem and thinking through stuff on your own. Okay, here's the schedule. This is really where you want to be, right? So this is a very important table. This tells you what we're going to work on every single week, and it also tells you what is due and how many points it's worth. So when you look at you should look at this every time you engage with the course. So you look at this thing and you're like, okay, week 1, here's what the topics are. And here are the activities, like the section activity, and here's what is graded. So you're going to notice that we have module 0. By the way, we always count starting at 0 in digital. So you always start at 0. I don't know who came up with starting at 1. So you basically have homework, and you can see it's worth 5 points, 5 points, 5 points. You got a course overview quiz, joining the Discord, and a typing test. These 3 activities have explanations in Brightspace. They're all a little bit different. Course overview is a multiple choice quiz in Brightspace. Joining the Discord is basically you join the Discord, take a screenshot, and upload it to the assignment folder. That shows me you can do that. And then a typing test. I'm going to have you do a 60-second typing test. You screenshot the result, upload it. You get 100% if you do it. I'm just curious how fast you can type. Notice that the first week, there are assignments due on Wednesday at noon. And from then on, everything we work on in a standard week is due the following Wednesday at noon. Okay. So if you look at week 2, you're going to have 2 sections, okay, and then a lab. And if you look at that, each section, like 3.1, has a homework assignment, and that's going to be a programming assignment that you do and upload. And then 3.2 has a homework that you do and upload. And then you do a lab. Notice that the labs are worth a lot more points because that's where you're going to spend a lot of time on it. But also notice that these are all due the following Wednesday at noon. The idea is that during week 2, you should be able to work through this material and get it done by Friday. But I don't make the deadlines due on Friday because you might be working or you might have other stuff, and maybe you do want to use the weekend to do it. So I make the deadline due the next week. So now the question is, when do you want to make the deadline? Right? If you give you the weekend, should we have the deadline be Monday at 8 a.m.? Not saying, what if you need help and you weren't able to get help on the weekend because the TA and I were traveling or something? Well, maybe it's Monday at 5. And it's like, well, there's really no good time to have a deadline. So what I've done is I said, all right, we'll do it Wednesday. That gives you basically 2.5 days to get help if you got stuck on last week's material. And then I put it at noon. And what I've learned is all deadlines need to be during working hours, because if I put these at midnight, everything goes wrong at midnight, okay? But if it's at noon, amazingly, the server never crashes. But if the deadline's at midnight, the server always crashes. So anyway, you go through this and you can see the entire course. You can see every module. We cover 11 modules. So we start off with just computer hardware and software, and then we go into the Linux programming environment. Then we do the basic constructs of C. We do math operations, decisions, loops. Then we look at header files. Then we look at arrays, and then we look at pointers, and then we look at strings, and then finally we end with files. Okay, so it's just the basic coverage of the main components of the language C. All right, so that is the syllabus. Now let's take a look at Brightspace. So I come back into Brightspace, and whenever I'm like flicking around through pages and I lose kind of my orientation, I just come up to the top and I click on the course. If you get even further lost, you can go back to your normal home page. But if I click on this, it brings me back to basically the first announcement for the week, right? So you'll see these announcements here. So then I'm oriented and I come over into content. And what I want to show you is just some of the tools that you're going to have. So let's say, for example, during module 1, you're going to take a multiple choice quiz. Okay. So you come out to here, you watch a YouTube video, you click on that, you watch it. It's 19 minutes. The slides are provided for you right here. So you can download all the slides, and then you come over and you take the quiz. When you click on that, you get a quiz, and you basically can just plunk in the answers. And the way that the quizzes are set up is you can open them and work on them and save them and then exit. And they basically go away at the due date. So the next Wednesday at noon. So make sure to submit it before the deadline. As soon as you get done with it, you can submit it, and then you get your grade right away, but you don't see the answers. And so these are just exactly what you would think. It's just a multiple choice question. What is the basic description of a computer? And you're like, and you just click them in there. And then remember, there might be multiple pages, but in this quiz, there's 18 questions. And when you get done, you come down here and you can do the old submit, and it'll give you a little notification if you didn't answer them all. But that's what a quiz looks like. Okay. All right. So then I come back, and let's say I wanted to look at slides. You just click slides and they open. That's pretty obvious. Let's look at once you get going though a little bit, and you're doing the programming. Okay. So let's come into let's say we get all the way down to module 5. When you look at this is going to be the flow. Like after you get through week 1 is all about orientation. Week 2 is all about getting familiar with the programming environment. Then you get in the flow and you just crank. So here's what it looks like. You come in here, you're like, okay, I've got 5.1, 5.2 in a lab. All right. And if I look at, I'm in week, 5, I come out to the syllabus. I'm like, okay, I'm in week 5. What am I doing this week? Scroll down. Sorry to make you car sick. I'm like, okay, we're looking at decisions. We're going to have 5.1 is on constructs called if-else statements. And there's a homework worth 15. And then the next one is 5.2. It's on a construct called switch case, worth 15 points. Then we do a big lab called the American Wire Gauge Calculator, and it's worth 60. That's a big dog, okay? So I come over here, and I'm like, okay, module 5, and I come down here, and I'm like, oh, cool. Here's 5.1. These are the calls to action. Watch, read, do, upload. So when you watch, you click on the video, and it'll bring you to a YouTube video. And let me show you kind of what these look like. Not that it's you're going to see what they look like, but I want to stress something. You come out to these videos, and basically you'll see there's a section where I'm like describing what the material is, but really that's a smaller part of it. What these videos are really about is when you come along and you see this. Let me show you. Once you transition, let me show you that you're like learning material. And then all of a sudden I will flip to a slide where you'll see a keyboard on there, and it's called Code Along. Okay, so once you're ready to start actually implementing the theory that we just talked about, you see this keyboard. That means it's time for you to fire up your terminal and code along with me. So I'm going to walk through examples. Sometimes they're verbatim of what the slides show. Sometimes they're a little bit different. So what I want you to do is I want you to code along with me. So if I'm typing too fast, just slow down the video or pause the video and get caught up. But if you do this, it's basically a strategy to learn where it's called I do, we do, you do. So you watch me, then you do it along with me, and then you do it on your own. And it's the best way to learn programming, okay? And another thing about learning it is you want to do a lot of it. So during the code along, you're testing, you're doing all the stuff. It's not graded. Once you're done, the homework is really trivial. But this is what it looks like, is basically you're going to be sitting at these dark terminals, these command prompts. We're going to log into a server that's at MSU, and you'll basically develop all your programs. You'll compile all your programs. You'll learn what that is, and you'll run all your programs. And all it is basically just pumping information to and from the screen. So if I kind of fast forward a little bit, this is now what these C programs look like. And you'll be coding along with me, and all this stuff will be making sense because I'll be talking over my code, and then we'll run it down here. And let's see, I'll get to the point where I'm actually running it. So now you can kind of see what a program looks like when you run it. It's very basic, but that's the point of this class, right? So right here, I'm going to run the program, and it's enter a value for A. You entered 33. Okay, so those are the types of programs we're going to have. They're simple, lots of them, low stakes. So that's the video. So then you come over here and you're like, all right, let me nuke that so it's not running. So then I come back here and I'm like, okay, I want to read something. You click on the book, and this actually will download this free book that's provided. And you can go to the section that I talk about, and it basically just describes the same information as what I did in the videos, except it's a textbook. So it covers a lot more than what you actually need. That's kind of the trick with programming languages that have been around for a long time. We look at variables and we just want to look at the key ones, right? Ints, floats, and doubles in cars. And the textbook will have to cover, all 100 of them. And so I try to make it so I just point you to the right spots just so you can see the information explained a different way. You might not have to ever open this textbook. It's just for reference, okay? So then you do this, you get the slides if you want them, and then you go down and you code, and then you upload your homework to an assignment folder. And so what you're gonna do is you actually come into here and you upload your code, and you upload screenshots of it working. And then what happens is that we will grade it and we will give you feedback on it. Okay. And so that's how you get graded on your homeworks. And that's how you also get graded on your labs. Let's go look at the lab. And then I think that's about it. So I'm going to come into the lab handout, and I want to show you the difference between a homework assignment and a lab. So let me show you, first of all, let me show you the homework. The homeworks are described on the slides. Okay, so if I look at the slides right here, you read the slides, slide 1 through 14, you go out here and you're like, where's the homework? It's like, well, it's on 15 and 16 of the slides. So if I look at the slides, let's look at this. I come out here and it's on 15 and 16. So I come down here to 15 and 16. I'm like, there's your homework. So they're really small, but they're just described in text and they're actually described in the slides themselves. So that's where all the homeworks are. All right. The labs though, a little bit bigger. So I come down here and I finally get to the lab and I have a video on just a rough description of what the lab is, but the lab handout is the big one. So you get this larger handout. This one's 5 pages and it describes very in detail what you're supposed to do and what the deliverables are. But it also, once you get going, we also use this as an opportunity to learn some basic information about engineering. So this one just happens to be called the American Wire Gauge Calculator. So I give you a paragraph on what wire gauge is and why it's important. And, it's not a learning outcome of the course, but it's just kind of an example of how you could use the C programming language to create a calculator where you have a user provide the amount of current and then you spit back with a wire gauge that they should use so that they don't burn their house down. And so you'll notice all the labs revolve around themes within the field of electrical engineering because that's, super important. No electricity, everybody dies. So all the themes are around that. That's my background. I'm in electrical engineering also. And then you're off and running. And so you can see that these programs are a lot more involved and you're doing it on your own. But I do give you the exact expectation of what you're supposed to do or what you're supposed to turn in. Okay, so that is Brightspace, and that really is all the information that you need to get started. Okay, so then let me close with a 2-minute introduction of myself because you're probably like, who is this chump that's talking in all these videos? And it's also good, especially in an online class, to know who the instructor is because you can feel somewhat disconnected when you're just watching YouTube videos. And I don't have my camera on a lot during the videos just because it's unnecessary. So you hear this voice and it's like, who is this guy? All right. So again, I'm Brock LaMeres and I'm a professor of electrical and computer engineering at Montana State University. And I've been here for 18 years. And what I do here is I teach classes in the area of computer engineering. So I teach programming and digital electronics, logic circuits, logic design, anything and everything to do with a computer. And then I do research in the area of embedded computers for specific applications such as aerospace and cybersecurity. Okay. So prior to coming to MSU, I actually graduated from MSU back in 1998. And I went to work for Hewlett Packard. And so I worked as a design engineer and I did digital system design. So I did logic circuits, I did high-speed digital. And so for 8 years, I worked in a lab, an R&D lab in Colorado, where we designed electronic test equipment for the computer industry. And so I worked with, our customers were Intel and IBM, and I learned a whole lot about how the computer industry works and the type of problems that those engineers are trying to solve. And really the whole ecosystem of hardware and software and how they're necessary and they feed off of each other. And so then I ended up getting my, I worked for Hewlett Packard's or HP, so they paid for me to get my master's and PhD on the side. So on nights and weekends, I went to class at University of Colorado, and I ended up getting my master's and my PhD. And it took like 6 or 7 years to crank those out. And I focused my research for my PhD on ways to reduce the noise in digital circuits. And then I became a professor at Montana State back in 2006. And so since coming here, what I focused my research on was really, really what happened was I focused on ways to exploit programmable digital circuits to solve problems. And I got interest from NASA right away on using that to build what are called radiation tolerant computers. And so for the last 16 years, I have been able to have a research lab that's funded primarily from NASA in order to build a computer that can withstand radiation. And you're like, what does that have to do with anything? And it's like, yeah, no kidding. I didn't see that coming. But here's just kind of the history of what I've done. We have developed a little computer that we call RAD PC, and let me flick down to the end here and show it to you. So we created a computer that's called RAD PC, and it is essentially a new type of computer that when you put electronics in space, it gets hit by radiation, and radiation can do a bunch of different stuff to a computer. But one of the things that I specifically look at is when it flips through and it flips like a 1 to a 0 or a 0 to a 1 and causes it to crash. So it doesn't degrade the material, this particular type of radiation, it basically just crashes the computer. So we came up with this idea that we basically have all these fault detection and fault recovery procedures that we put on a programmable logic device called an FPGA. And you'll learn about that if you continue in this program. And it was pretty cool. And so we ended up starting to get a series of grants where NASA was like, okay, build a little prototype and fly it, then build a better prototype and fly it, and build a little bit more and a little bit more. And so we actually have had the opportunity to put this into space in the form of satellites. So this is an example of a satellite that we built at Montana State where it's the little computers in here, the satellite's the size of a loaf of bread, and it actually got put into space from the International Space Station, and so it orbited Earth for 2 years. We ended up doing another one. This one was the Bobcat head one, and this one also got put into space and orbited for almost 2 years. And then we've done all sorts of things, such as sounding rocket launches, where you just shoot it up into space and then it comes right back down. We actually also went to the International Space Station, and we've done tons of balloon testing. And then we got the big call from NASA to go demonstrate this on the surface of the moon. So we are actually, we've delivered a payload carrying this little computer that will go to the surface of the moon later this year, later in 2024. And sorry to make you car sick. This is what it looks like. So it's a little payload, and you can see here, this is the lander. This is a little mock-up of it. But this lander is almost built, and it'll go up on a SpaceX rocket, hopefully in October, and it'll head to the moon and land, hopefully, and then we'll collect information about how the computer can run in the presence of radiation as seen on the moon. And so it's pretty awesome, right? So and then as part of that, what I've done is kind of just to help my own teaching and to know what the students know before I hire them in my research lab. I've had the opportunity to write a series of textbooks to help the classes that I teach. And so I've written a textbook. I haven't written it for this class, but if you continue on, you'll take classes where you use a textbook I wrote, and we basically cover everything that goes through this. So now, why is any of this relevant? Okay, I just tell you this because computer programming, digital hardware, I mean, this is what I do. This is what I absolutely love. This is what I've spent my entire career learning about. I teach it. I write books to help teach it. I create videos for others to learn it. I do research in this area. I have started a company in this area. I used to work at a real company before becoming a professor. So this is what I live and breathe for. This is my absolute passion. And so I'm excited to teach you this summer about one small part of the computers. And then hopefully this will spur some motivation for you to continue to learn about more of the computer and ultimately get your degree where you will be savvy enough to get a job and contribute to, society and industry industry as some computer-ish person. So, all right, that's me. That's it for this video. At this point, you should be able to launch in the activities, and I look forward to working with you this summer, and good luck.